How do we determine the magnitude of a vector? So to determine, again, if I have to write our vector, let's say again we have a vector A on a 3D space, then you have a vector A. So how would we determine its magnitude? Now, notice that our vector A has a propagation. Vector A is propagated along xy plane and along z axis. So we could consider the angle measured from the z axis towards the vector A. Let's call this as angle theta. And the angle measured from x axis towards the propagation of vector A along xy plane. Let's call this as angle. I use in our material, I use phi. So in this case, if you notice, using the information of this angle, we could determine its propagation along y-axis. So let's call that propagation. What I mean propagation is that expose this with a light coming from this direction. This will create a shadow along y-axis, and that's what I mean when I say propagation. In that case, that propagation can be considered as a y. If you have a spotlight from here, this vector along x-axis, that's its propagation of vector A along xy plane. We could label it as x sub y. Then we could have here a propagation along x-axis, and let's call that a x. That's point ax. Also, it has its propagation along z-axis, and let's call that as a sub z. Okay, so basically our vector A has its propagation along y, it's called ay. Propagation along x-axis, it's called a sub x, and then along z, it's called a sub z. So how would we determine its magnitude? How long is this? Basically, we could just simply use the Pythagorean theorem. All of these are orthogonal or perpendicular to one another. Ax is perpendicular to a sub z and a sub y. So we could determine the magnitude of a. As I said, we'll just simply use a to signify the magnitude or the length of this vector. When I say magnitude, it's if we're dealing with force, it's so what we mean is the amount of force. If we're dealing with displacement, what we mean when we say magnitude, it's the length. So for acceleration, so how fast is the changing of velocity? We're just dealing with numbers, not the direction yet, because as you can see on this illustration, directions are already given. Angle theta with respect to z, and angle phi with respect to x-axis. So therefore, we could determine the magnitude of A to be using the Pythagorean theorem. So the length would be given by square root of ax squared plus ay squared plus az squared. So you'll just have to determine that. But how, we will have a detailed application. But the point is, you just have to determine the ax, ay, and az. Once you have the value, then you can determine the magnitude of the vector. Suppose, for example, so if you have a vector A, basically axi plus ayj hat plus azk hat. If you remember earlier, if you can still remember earlier, the unit vectors indicate the direction, I, j, and k hats. Now, in this paper, I indicate to you the length of ay, the length of ax, and the length of az, but no unit vector. But we know they are all projected along x, y, and z. So in this case, if you have this vector A, then it must have its magnitude and its direction. Magnitude along y-axis and its direction indicated by j hat. So for example, you have a vector A for, if we're dealing with whatever units, no? Units might be for force, it might be for displacement, it might be for velocity. Okay? So I'll just use units for whatever unit of measurement that we're going to use. And then it's I hat plus, let's say, 5 units J hat plus 2. Let's just use small numbers so that the calculation would not be difficult. I, J, K hat. So in this case, you have a vector. As you could see, as I said earlier, vectors are represented by at least two numbers. In this case, in 3D space, which of course, that's what we have in our normal, ordinary lives. No, we have the height, length, and width. It's 3D. There are other coordinate systems that you may use, but that would be for future mathematics subjects that you have, or in physics subjects that you will encounter. But for the meantime, let's just limit on both Cartesian and the polar coordinates. When I say Cartesian, this one, x, y, z, the moment I introduce angles in the length of the vector, we are having a polar coordinate system. So just to help you visualize this vector A, so again, we could plot it along x, y, z. I'm just estimating. So this is 1 unit, 2 units, 3, 4, 5 units. And then along, oh, so y din sa x, so we should reach 5 units, and so on. Then for x, 1. Now, it's very important if you're going to use this kind of approach. It's more of a geometry. So you have to be very accurate on the scaling, no? But I could solve it analytically later. But let's allow me to show you the meaning of this vector with this given values. So 1, 2, 3, 4, 5. So if you have this vector now, it has 4 units along x-axis. So 1, 2, 3, 4. Okay, so I'll start here. And then it has 5 units along y. So 1, 2, 3, 4, 5. So make sure when you write, dapat ito na dots should be parallel to y-axis, and this extended line should be parallel, of course, to x-axis. Another is this now. This is a projection along xy only, a x y. You may write to indicate that it's a vector. Okay. And then you could go up with along z2 units. So this is now our vector A. So that's vector A. If we are going to plot that, but our intention actually is just to calculate for the magnitude. So I'll just demonstrate this to you so that you can see what we mean by this particular vector in graphical representation. So again, using the Pythagorean theorem, we could calculate for magnitude A equals 4 units squared plus ax squared, ay squared. So that's 5 units squared plus 2 units squared. So in this case, using Desmos, you have 4 units squared plus 5 units squared plus 2 units squared. Okay, so the answer is 6.7 in the calculation. First is 6.7 units, but that's not yet the final answer. If you notice on all of our exercises, I always emphasize the significant figures. So in our given example, we have only one significant figures, and that's the least number of significant figures. So our final answer should be or. So we have 7 units